GM and GN, and welcome to today's English seminar of Dapp Learning and StarkWire. Today, this event is co-organized by the StarkNet Chinese community and Dapp Learning community. We will have two sharing sessions. Today is about, the topic is about the Cairo 1.0, and we invite Lucas as our presenter to tell us some knowledge or technologies you need to know about this Cairo 1.0. And tomorrow we will have another seminar and knowledge sharing. Knowledge share is the topic is that it's a recursion proof. As presenter Henry, is the StarkWire developer ambassador, but he cannot show up today. And so before we start, let me give you a brief introduction about the StarkWire, StarkNet, and the Dapp Learning community. So let's start from the StarkNet. StarkNet is an open programmable Ethernet layer 2 scaling solution developed by the StarkWire that uses Stark validity proof to enable off-chain computation and on-chain verification. And Stark validity proof is secure, reliable, and efficient, ensuring that StarkNet is an infrastructure built for future mass adoption. Now let's move to our own community. That's the Dapp Learning. The Dapp Learning, we have a lot of members from the Chinese communities, and we are designed for developers to step into blockchain Dapp development, covering DeFi, NFT, DAO, crypto projects. And we hope we could not only give junior developer a feasible and easy to use blockchain Dapp Learning roadmap, but also present advanced developers with a platform for communication and cooperation. By the way, our Dapp Learning is a non-profit organization. And you may notice that Gitcoin has a new wave, Gitcoin 15. If you like to support our community, please donate us on the Gitcoin. Okay, I think I have finished this introduction part. And I'm Alex. You can just call me Alex from the Dapp Learning community. And Lucas, can you hear me?
Yes. So thank you for inviting me and organizing this event. I'm Lucas. I'm a StarkWire developer advocate. I work with Seabook and Henry. And today I'm going to speak about Cairo 1. So first, let me share my presentation here.
One more thing. Sorry to interrupt. So during this presentation, feel free to ask any questions in the comment area, or you can send your questions in the WeChat group or our Discord channel. Okay, back to you, Lucas.
Okay, thanks. So let's speak about Cairo 1, the next evolution of Cairo. So Cairo today is a programming language kind of hard to use, but it has been used in production for about 2 years now. It started with StarkX, which is our layer 2 application-specific rollup, and a year after with StarkNet, which is the layer 2 that you all know. And it has processed around 200 million transactions and $600 billion of cumulative trading. There are around 15,000 Cairo files on GitHub, and it's way easier to write than polynomials. So this code is Cairo1.0, which is the first minor release of Cairo. It had already some abstraction, but it was way harder to write than now, because now Cairo looks like that. We have Open Zeppelin libraries, which are really convenient. We had some syntax updates, so it looks more like Rust or Solidity. So it's really easier to onboard on Cairo. For the record, Cairo is an assembly language efficient for Stark. It has been created by Starkware for StarkX because at the time they had to write the polynomials manually, which was really cumbersome, and to update anything, it was really hard. And it's really hard to edit polynomials. So they wanted to create something that would enable to generate Stark securely and easily. So they came up with Cairo, which was not meant for external use. So it misses a lot of tools and it's not really extensible. For the tools that are missing, we lack a package manager. For now, there is pip, but it's not that convenient. We don't have that much standard libraries. We have the Uint library, but it's not really easy to use. And we miss some basic syntax things like loops or error management. So that's the state of Cairo now. It's a bit like hell, but it will change with Cairo 1. You'll see it will like really improve the life of developers. Yeah, that's the goal of Cairo 1. It's to make developer happy. So if you want to learn and build on StarkNet, you'll love the new update of Cairo, which will be the first major release. To create that, we have a dedicated team that fully works on the compiler. And the compiler is rewritten in Rust, which will enable to have a better base, because right now the code is really messy. I don't know if someone has tried to read the compiler, but it's really hard to understand what's happening. With the rewrite, it will be like way easier. And the good thing is that all the code that you write now will be easily portable to Cairo 1. So you don't have to wait for Cairo 1 to start learning Cairo. And in a sense, you'll be like you'll have an advantage to relearn now. As it's lower level, you'll understand how things work, and it's always good to know how everything works. So the goal of Cairo is to improve the syntax and to add some features. So first, right now, if you want to create a variable, you have to know if you want to create a let, a temvar, or a local. This is hard to know, and this will disappear in Cairo 1. The compiler will take care of everything, which means that you will only declare a let, for example, let x equals 1, and the compiler will know if it's a temvar or a local or just a let. This will enable to deal with revoked references more easily. The compiler will handle almost everything, I think. So I think that's a good improvement. We'll have more data types. For example, we'll have int as a standard library, which means that you'll simply have to type your variable as an int, and it will act like an int. So for now, if you want to have an int, you'll have to use the uint 256 library, which is not really convenient. You can't use like the regular operators for the division, multiplication, and everything. With the native int type, you will be able to perform this. So for example, if you divide 9 by 3, if it's typed as a felt, it will act like a felt. So it will be a modular division, which will output a weird result. If you type it as an int, it will just output 3, which is way better than the current behavior. We'll also be able to manage errors. So for now, there's no error management. Basically, if you want to check that someone has, I don't know, if you want to check that your user has exactly 1 token, you assert that his balance is 1. If it's not 1, then it fails. Now you'll have something like Rust or Golang, which means that the function will return a value and an error, and you can check if the error is null or if the error is populated. And then you can either choose to propagate the error or to just handle it. So it creates a try catch. And we'll have native safety for mathematical operations, which is always good. As I said, the compiler will be better. The base of it will be like way cleaner. It will be written in Rust, so it will be really efficient. That means that now when you want to compile a big file that imports some libraries, it won't take an hour like now. Python is good, but it's really slow. That's why we're turning to Rust. And we will be able to add more features more frequently because the base will be easier. So you could also contribute to the compiler. We'll add a package manager. Either it would be Cargo, the Rust package manager, or a specific one that we'll create. We don't know yet. And we'll also add language server, which is like a small extension on VS Code that will help you detect errors when you write Cairo. I will show you at the end how it works. And the repo will be public, so you'll be able to contribute and follow what's happening. Cairo1 will also introduce Sierra, which I will talk more about later. So right now, the state of StarkNet is that transactions are executed in native Cairo. It means that we don't sandbox anything, so it's more efficient, and it's kind of safe because Cairo's memory is immutable, so a transaction can't mess with the OS memory. But the good analogy would be if Ethereum executed the transactions on plain x86. It would be a disaster. So for now, we do that to be more efficient, but we can't prove a transaction that fails. And that's a big problem because if we can't prove a transaction, we can't include it in a block, so we can't charge for fees. So if someone wants to spam us with the transaction that fails, we can't do anything. Right now, we try to mitigate it with the validate entry point in an account contract, which will basically allow us to take fees for a transaction that fails, but it's not perfect. So we want something to be fully provable, whatever happens in it. So for example, now when you will want to assert that someone has exactly one token, it will be transformed to an if, and the if it's false, it will return an error, and then you will choose how you handle it. Either you propagate it in the transaction and you revert it, but it won't be a revert, like a real revert. It will be provable, so we'll be able to take fees, and it will allow gas counting easier for us. The solution is called Sierra, which stands for a safe intermediate representation. And yes, the result is always provable by construction. So the new flow would be that you will write your code in high-level Cairo, so in Cairo1, and then it will be compiled to Sierra, which is the safe intermediate representation, and then it will be compiled to Cairo bytecode. The compilation from Sierra to Cairo bytecode had nearly zero overhead, so it's really convenient because it solves many problems for us, and it doesn't mess with the code, introducing like really unoptimized contracts. So Sierra is really a great thing. For the development process, the first steps has been taken. We have a POC that works. It can compile some code, but not really complex one. I will show you right after a small example of the compiler. It's expected to be released in 3 months, a bit before Regenesis. And the Cairo1 repo will be public soon, I guess. So you'll be able to track what happens there, to submit PRs, and to try it before it's released. So let me show you how it works. So this is a small snippet of Cairo1. It's basically a Fibonacci function that will compute the Fibonacci sequence. So you just enter the number you want to compute, the first two elements, and then it will match on the number of elements. So match works like in all the other languages, like Rust. You match on n, either it's 0 and then you return a, either it's everything else than 0 and it returns Fibonacci, a recursive function. And so this compiles. I can show it will appear red, but don't worry, it's expected. So this is this. I'm gonna zoom in, I think. This is the Sierra representation of this snippet of code. You don't have to know how to code in Sierra, don't worry. It's just so that you know how it works. And here is Chasm, which is Cairo Assembly, which is the low-level Cairo that they used to write at the first version of Cairo. And this code will be compiled to Cairo bytecode. So you see that everything works, and that's the matching, like the match keyword, will enable a lot of things. So for example, for error management, it will be really convenient because you can have something that returns an error, and then you can match on your error. If it's null, then great, there will be no error. If there is an error, you can do something. You can either propagate the error and revert the transaction, or you can just do whatever you want, which will be somehow like a try catch. I hope that was clear. And if you have any question, please ask them. I know that there were some questions that were already asked. I'll get them and answer them in a second.
Yeah. Okay. Yeah. Thanks for sharing, Lucas. Yeah, I can see Cairo is becoming more efficient and safer. Yeah, in these released versions. And here we prepared some questions for you about the Cairo 1.0 and some relative specs. So the first one is that, I mean, for you, a developer and advocate, is there any, I mean, favorite parts in Cairo 1.0 you like?
Yes, so the error handling is for me like a huge thing because right now we don't have a choice. If we want to handle errors, we'd have to have a multiple if else, which is not convenient at all.
Yeah.
And now with the error handling and pattern matching, it will be really easy to deal with errors. And also the native int type is huge. Well, basically all the native types that we'll introduce, it's super helpful. And also the for loops, because I know that everyone dislikes recursion. So the for loop will be like a huge improvement for everyone, and it will be so much simpler.
Okay, see. One more thing from my side is just now you mentioned the error handling. Is this error handling similar with the Rust? Yeah.
Yes, it's really similar. It in the syntax and in the way it works, it will be really similar.
Okay, I see. Because I mean, previously I I don't have too much, I mean, idea about how to handle error in the blockchain like Solidity or some other languages.
Yeah, no, it will be like really the Cairo1 is supposed to look a lot like Rust, so it will be similar in a lot of points.
Yeah, okay, got it. Okay, thanks for your answers. Let me check the next. Okay, I know Cairo, I mean, it's written in Rust. So how is Cairo 1.0 compared with the Rust in terms of the use?
As for the syntax, it will be really similar, but for everything else, like the way it works underneath, it's really different. Well, basically, what will change is only the syntax. The bytecode stays the same, so it doesn't change how Cairo works. It will just be a matter of compiler and syntax. And for the performance, we'll integrate the Rust VM, Cleopatra, I think, which is developed by Lambda class. So Cairo will be much more efficient with the new VM also.
Okay, I see. Okay, yeah. I think the third question is raised by some members who are interested in the transpiler. Yeah, it's RAP. So is the RAP going to become more efficient to transpile from Solidity to Cairo? Yeah, I mean, from my side, I'm not quite familiar with the RAP or how RAP works. Yeah.
Yeah, so basically warp, it compiles the solidity to YUL, which is an intermediate representation of solidity. And then from the YUL code, it reconstructs a Cairo contract. I don't really know how it will handle Cairo1. I guess it will maybe just compile solidity to Chasm, but I don't really, maybe to Sierra, but they will have to rework on Warp. So I don't really know how Nethermind wants to handle this.
Okay, so the Nethermind is responsible for this part?
Yes.
Okay, gotcha. Yeah, okay. And a member mastering at Python asked, is there any suggestions for him or her to learn Cairo? I mean, with the basic knowledge about Python. I know it's a totally different, or maybe we can change this question to another one. Is there any suggestion you want to give us? I mean, to the new Cairo developers or learners, maybe Rust or yeah, it's up to you. Yeah.
Yeah, basically, if you're coming from Python, you can use, like, there are a lot of Python tools for now, so you can use them. As for the Cairo syntax, you won't have any choice than to learn a new one, which is different from Python.
Yeah.
And for newcomers, you can do all the tutorials that we have under the StarkNet edu repo. You can also check the Only Dust Stark links, which is an equivalent of the Rust links, which holds you by the hand to teach you how Cairo works in every concept. But if you do that, you'll have no trouble understanding Cairo. You can also come on Discord and ask questions. People will answer you, or I will answer you. So yeah.
Okay. So now I'm a Rust baby developer, and I think it could be easy to, I mean, to use Cairo, right?
For the Rust developers, yes. With Cairo1, basically, it will be really similar to Rust, so you'll have no trouble getting into Cairo.
Okay, gotcha. Yeah, I will try it after today's meeting. Yeah. And another question is about the layer 2 native apps. I mean, in your side, what do you think? How Cairo will help the layer 2 native dApps in StarkNet? I mean, you can narrow down, I mean, any aspect like security or efficiency. Yeah.
So yeah, as I said, with the Rust VM, it will be much more efficient, and on StarkNet, computation is really cheap. So we will see a lot of games, I guess. Of course, we'll see DeFi. We already have DeFi, but we'll see much more games or AI or computational heavy dApps than on other chains. For example, we have an app which is on mainnet, which is an AI for trading that basically is an AI on L2 that sends messages on L1 to trade. I think that's super cool, and that we'll see a lot of these things in the near future.
Okay, I see. Yeah. Next, I think it's a question about comparisons. Yeah, any difference between the Cairo and ILO? Did you know ILO? I mean, the L2 privacy blockchain.
Isn't it an L1?
I mean, Cairo and ILO. I mean, ILO blockchain.
Our blockchain basically relies on Stark. ILO or whatever, I can't say the name, but whatever, is relying on Snarks, which is a pretty big difference. For example, Snarks need to have a circuit. So you need to generate your circuits when you start your blockchain, and you need to generate a random number. Once you have generated your circuit, you can't modify it, or it's really complicated. So you have to think of every possible thing you need to have a suitable circuit. And for the random number generation, if anyone knows this number, he can create every snark he wants. With Starks, we don't have this problem because we don't have a circuit and we don't have a trusted setup. So I would say it's safer and it's really easier to use.
Okay, good. And how about the Polygon Maiden? It's the layer 2 solution from Polygon.
You mean
maybe
Hermes?
My pronunciation is not correct.
No, I just Polygon Maiden.
Yeah.
I don't know. I didn't really look into it.
It's okay. Yeah. Okay. I see. Yeah. Okay. And the last one, yeah. Now you have answered 6 questions, but yeah, last one, and yeah, it's I mean forward to the future, and in your mind, what's will it look like in the StarkNet ecosystem in 2 or 3 years? I mean, Cairo, like we will have Cairo 2.0 or 3.0 and many versions.
That's a really good question. I don't know how long will Cairo 1 last, but I don't think that we'll see a major release that often. So I guess we'll still be to Cairo 1, but we'll have way more tooling, way more libraries. Everything will be way faster and easier to do.
Okay, I see. Yeah, definitely. I think it's a right direction for any language and the ecosystem. And yeah, another small questions, yeah, like sub questions. So, what kind of dApps in the StarkNet you expect, like DeFi or NFT or GameFi or some new stuff?
I guess we'll see a lot of games because of the computation and a lot of AI, which will be really cool to see and probably something that we can't imagine. Obviously, yeah, there will be a lot of DeFi. We already have a lot of AMMs, a lot of NFT projects.
Yeah.
So of course we'll have them, but we'll also have some use cases that were impossible on blockchains before that will emerge on StarkNet.
Okay. Yeah, totally agree. Especially for the GameFi and all. I mean, currently, GameFi cannot do too much computations in the layer 1 or other blockchains. And yeah, as you said, maybe in the future we may have like 3A style GameFi in the StarkNet. Yeah, okay, let's expect. Let me check the comment area or Discord, WeChat. Please wait for a while. Okay. It seems like we don't have any questions or problems raised by our members or yeah, someone. Okay. I think it's done. Yeah. Thanks for telling knowledge about the Cairo 1.0 to the Chinese communities. And yeah, also thanks to the StarkNet cooperating with this event. And last is the Dapp Learning. Thanks for them to giving us a chance to talk with the Cairo 1.1 and meet the advocate face to face. Okay. I think yeah.
Actually, I think we have some questions for the community as well. Like, what's a good language for you guys to pick up? Obviously, Cairo is a very new language. So what ideally is a good language for you guys to pick up? And what kind of tutorials or examples you guys need to help you guys?
I didn't hear you quite well. Can you speak a bit louder, please?
Maybe.
Can you guys hear me?
Yeah. Very clear.
Yeah. Just actually, I want to ask community, like, what can we do to help the community to learn the language? Like maybe more real examples, real application examples, or like how to help the community to learn the Cairo is the question. You hear me, Lucas?
Yeah. Yeah. So what can you do to help the community learn Cairo? Well, explain how everything works, display tutorials. Yeah, even getting feedback from the community is really valuable because
yeah. So yeah, I would like to get some feedback from the community. Like, from that learning point of view, anything we can do to help community to learn Cairo?
Maybe I can repeat the question. Yeah.
Actually, this is the question for the Dapp Learning community, not for Lucas.
Okay. I see. I think the Dapp Learning. We are knowledge sharing communities, and I think the easiest way is to translate or provide some help when members learn the Cairo tutorial or the StarkNet, and if we found any questions or issues in their tutorial or their codes, and we can give them feedback and try to contribute. I think that's an easy way for me. And yeah, and for the advanced one, I'm not sure, but like Lucas said, they have their own repo, yeah, with a lot of tutorials or codes. You can review them or try to make some contributions that could be like in depth, and yeah, jump into the StarkNet and Cairo. Yeah. And any question from all of the participants? Okay. Okay, I think it's done, and yeah, thanks for everyone attending and showing up this event. And yeah, please remember tomorrow we will have another session, our knowledge share event from Lucas. Sorry, from Henry, another developer ambassador. Yeah, the topic is the recursion proof, and the time is the same. It's 1 p.m. UTC. And if you like it or learn more about this topic, please let me set up your schedule and attend our meeting tomorrow. Okay, guys, and I will hop off, and thanks for attending, and enjoy the rest of your day. And we will see you in the metaverse.
Thanks, Lucas. Thanks, Alex. Everyone. Bye.
Thanks.
Bye, guys.
Bye.